In this section, we're going to talk about solving equations by using quadratic methods. So this is solving equations, solving all sorts of types of equations, but just combining, completing the square, quadratic formula, square root property, like those kind of things to actually now solve. It's not going to be just nice, clean factoring for the most part. It's going to have to use some different methods here. So let's just go through our process. So in this first one, we have x minus the square root of x minus 1 minus 3 equal to 0. Let's get the radical by itself, just like how we would on any other normal problem. And I'm also going to add 3 over. So I get negative square root of x minus 1 equals negative x plus 3. I talked about this before in a previous section or a previous video where we have this negative square root of x minus 1 and we know we're going to need to square it. I just like feeling comfortable. I'm going to divide everything by negative 1. You probably don't need to. I just want to be better safe than sorry here. So I'm going to divide everything by negative 1. So negative x becomes positive x. Then positive 3 becomes negative 3. Now, and plus it's going to make our multiplication a little bit easier on the back half. So now I have the square root by itself. So let's square both sides. Everything seems pretty standard up to this point. Like if you think back to solving just quadratics and everything, just trying to get the x by itself. So we're going to square both sides. So that's going to be x minus 1 equals, and then we have x minus 3 squared, which is x minus 3 times x minus 3. So we're going to multiply all this out. X times x is x squared minus 3x plus 9. So x squared minus 9x plus 9. So it's x squared minus 9x plus 9. We have to set up a quadratic. So let's subtract x and add 1. So 0 equals x squared minus 10x plus 10. This is where the quadratic methods come into play. Because I have this trinomial, I can't factor it using just two numbers that multiply to 10, add up to negative 10. Nothing's going to work there. So I have to either use complete the square, quadratic formula, have the freedom to do whatever you really want. I like sticking with the quadratic formula. It's easiest for me to just boom, here it is, go through it, and then get the answer. So I'm going to do quadratic formula. So my a term is 1, my b term is negative 10, my c term is positive 10. So negative b is going to be negative 10. So positive 10 is what's going to become. Negative b plus and minus the square root of b squared. So negative 10 squared minus 4 times the a term of 1 times the c term of 10 all over 2 times the a of 1. Negative 1 times negative 10 is positive 10 plus minus the square root. I'm going to go to my calculator. So negative 10 squared minus 4 times 1 times 10. That's going to be 60. 2 times 1 is 2. Square root of 60 is 4 times 15. Square root of 4 is 2. So that's going to be 2 root 15. So 10 plus minus 2 square root of 15 all over 2. From here, we can factor out the 2 from here. So 2. Let's factor out a 2. So we get 5 plus and minus square root of 15 over 2. 2 is canceled. So x equals 5 plus square root of 15 and 5 minus square root of 15. And then you could always check and plug those answers back in, but just to save myself some time, I'm not going to do that extra step, but you can check and make sure that they work out. So next one, solving this rational equation. Think back to rational equations. How do we solve these? To solve a rational equation, we want to multiply by the LCD. So the LCD in this case is going to be x times x minus 1. So everything is going to need to be multiplied by x times x minus 1. So I'm multiplying this side by the x times x minus 1, and I'm multiplying this side by x times x minus 1. So let's go through and make that multiplication. So on the first part, when I multiply by x times x minus 1, the x minus 1s are going to cancel on that first fraction here. So the x minus 1s are going to cancel there. So that's going to be 2x times x. So 2x squared. So right here. So this is x times x minus 1 times 2x over x minus 1 for that first multiplication. The x minus 1s are going to cancel. So you're left with x times 2x, which is 2x squared. And then we're doing x times x minus 1 times x plus 2 over x. So what is that going to look like? That's going to be x, and that's minus. So x times x minus 1 times x plus 2 over x. So the x's are going to cancel. Change colors. X's are going to cancel out, leaving us with x minus 1 times x plus 2. So that is going to be x squared plus 2x minus x minus 2. X squared, 2x minus x is x minus 2. So we have 2x squared minus x squared plus x minus 2. Notice how I wrote that? Because this was minus x plus 2 over x. This was minus x plus 2 over x. So when I did all that multiplication there, the x's canceled. So I did x minus 1 times x plus 2. But since we're subtracting off this whole thing, you want to make this as minus all of that. So you could have distributed the minus already, but I didn't want to do too many steps in once because I know that step is a little bit complicated. That's the key to this problem. I have one step right there. And then on the right side, 5 over x times x minus 1 times x minus 1. The x's and the x minus 1s are going to cancel. So we're just left with 5 on the right side. Let's distribute the minus. So this is 2x squared minus x plus 2 equal to 5. Let's set up a quadratic. So I'm going to combine like terms. I'm going to get everything over to one side. I have like terms of 2x squared minus 1x squared is x squared minus x. I'm going to subtract 5. 2 minus 5 is negative 3 equal to 0. So I just combined like terms. 2x squared minus 1x squared is 1x squared. I moved over the 5 because I want to get this equal to 0. Now we have a quadratic. My only way to do this, I cannot factor that. So I have to use the quadratic formula again, or complete the square if you want. I'm just going to go ahead and use the quadratic formula. So negative b. Wait, let me go back. Okay, I did. So negative b plus minus the square root of b squared minus 4ac. If you didn't have quadratic formula memorized after the quadratic formula video, probably do now, after doing it so many times, over 2a. And it's not a big deal if you have to refer to it a couple times. So I'm going to do the inside of that radical, so negative 1 squared minus 4 times 1 times negative 3 is 13. So positive 1, because negative times negative 1 is positive 1, plus minus the square root of 13 over 2 times 1 is 2. So we just end up with x equals 1 plus square root of 13 all over 2, and x equals 1 minus square root of 13 all over 2. For a rational expression type of problem, you do want to make sure that none of the answers are going to make the denominator 0. So this would, x can't be 1 because 1 minus 1 is 0. We can't have 0 in the denominator, and x cannot be 0 because then that would be 0. But neither of our answers are anywhere close to that kind of clean answer, so we're okay. Number 3. Moving along here. Number 3. X to the 4th minus 5x squared minus 36 equal to 0. So we have x to the 4th. X to the 4th, we can think of that as just x squared times x squared, right? X squared times x squared is x to the 4th. So don't think of it as like, oh, this is some crazy quadratic. Look, think about the factoring. If I can find two numbers that multiply to a negative 36 and add up to a negative 5, That would be negative 9 and positive 4. Because negative 9 times positive 4. Negative 9 times positive 4 is negative 36. Negative 9 plus 4 is negative 5. So this would just factor to x squared minus 9 and x squared plus 4. So it's just factored. Instead of x times x being x squared, x to the second is x to the fourth. But now you have to find that next step where we have a difference of two squares. X squared minus 9 is x minus 3 times x plus 3 times x squared plus 4 equal to 0. So we do have that difference of two squares. Then we generate some potential answers here. So now we have to set all three of these factors equal to 0. So x minus 3 equal to 0, x plus 3 equal to 0, and x squared plus 4 equal to 0. So let's solve both of these. This one's going to be x equal to 3 because you just add 3. This is going to be x equal to negative 3 because you subtract 3. And then I'm going to subtract 4. So x squared equals negative 4. Take the square root of both sides using the square root property. So x equals positive negative. Square root of 4 is 2. Square root of negative 1 is I. So plus minus 2i. So our solutions would be 3, negative 3, 2i, and negative 2i. Good problem there. So we just really had to use the square root property there. It's like really the only new skill that we had to address. Let's move on. Just got two more, I think. Yeah, just two more. So next one, x plus 4 squared minus x plus 4 minus 6. So you might think, oh, I have to multiply x plus 4, multiply all that out. Binomial times a binomial, multiply all that out, then combine like terms, like and all that. And maybe that would be a route that you can take. But I want to show you a different strategy here. Where if you have this x plus 4 being squared, minus x plus 4, you notice this factor of x plus 4. You notice this term of x plus 4. Let's rewrite this. Let's say y is equal to x plus 4. Look what happens. If I substitute y plus 4, or x plus 4 for y, look what I get. I get y squared minus y minus 6 equal to 0. Look at that trinomial. Now all I'm looking for is two numbers that multiply to negative 6. Where are my lines? Two numbers that multiply to negative 6 and add up to negative 1. That's negative 3 and 2. Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. Factor. So let's set this as y minus 3 times y plus 2 equal to 0. Set both factors equal to 0, just like how we've talked about before. So y minus 3 equal to 0, y plus 2 equal to 0. Then look what happens. So if I solve for y, I add 3, y equals 3, subtract 2, y equals negative 2. Now, all I have to do to figure out what x is, because we created a new variable of y, so we don't know exactly what x is, but I can substitute back in x plus 4 for y. So now I'm going to say x plus 4 is equal to 3, and x plus 4 is equal to negative 2. Subtract 4, x equals 3 minus 4 is negative 1. Subtract 4, x equals negative 2 minus 4 is negative 6. Those are my two solutions, negative 1 and negative 6. Yeah, nice problem there because it looks kind of complicated with this x plus 4. Like this looks like a potentially pretty challenging problem. But just substitute out because it's the same thing. Now, if these weren't the same thing, if there was like x plus 4 and x plus 3, then we'd be in a little bit of a situation there where we'd probably just have to multiply it all out and then combine like terms and hope to get a decent trinomial from there. But in this case, it works out nicely where we can just substitute out that y plus 4. Now, number 5, definitely a little bit of a challenge question for this section. X to the 2/3 minus 7x to the 3rd plus 10. So what you have to find here is same kind of concept here where we have this term of x plus 4. you have to find that this is x to the 1/3 squared. It's hard to see though. That's a hard piece to catch on your first look at it, because this is x to the 2/3, so that's really x to the 1/3 squared, because x to the 1/3 squared is x to the 2 times 1 is 2, so 2/3, so that makes sense. But then from here, you could do the same approach as what we did before. You see how we have this factor, or term, I keep saying factor, this term of x to the 1/3, x to the 1/3. So we can then substitute out, so you could say y is equal to x to the 1/3, substitute out that x to the 1/3, so you get y squared minus 7y plus 10 equal to 0. Factor, so that's going to be y minus 5, y minus 2, because negative 5 and negative 2 multiply to positive 10. Negative 5 plus a negative 2 is negative 7. Do the same thing as what we just talked about a second ago. So y minus 5 equal to 0, y minus 2 equal to 0, y equals 5, y equals 2. Then replace y with your x to the 3rd. So x to the 3rd equals 5. X to the 3rd equals 2. I'm saying third, 1/3. So now I have to solve for x, which is, this is x to the 1/3. That's really the cube root. X to the 1/3 is the cube root of x. So if we're solving for the cube root of x equal to 5, how do we solve that? We raise it to the 3rd. So we raise it to the 3rd power. So x equals 5 to the 3rd, which is 125. And here, this is the cube root of x equal to 2. So raise x to the 3rd. So that's 2 to the 3rd. So x is equal to 8. And then you can check them, but just to save myself some time on these videos, I'm not going to check unless I know of an issue that I might need to look out for. But those are our solutions, 125 and 8. So good problems there. This is just combining everything that we've been looking at with quadratic methods, completing the square, quadratic formula. And all these problems where I use quadratic formula, you could have used completing the square if you prefer that. I just prefer quadratic formula. It's completely your preference.